Water, water everywhere, and not a drop to drink. The line from the rhyme of the ancient mariner is as true out to sea as it can be while cruising through the islands of the Salish Sea. So let's talk about why and take a look at our Watermaker. The islands of the Pacific Northwest certainly are green and lush, and the entire area is known for good rainfall, with many areas being considered coastal rainforests. However, there are two main factors that make drinking water limited to completely unavailable in many of the marinas. For one, the islands are largely rocks, with very little in the way of area to hold water for wells, for example. Secondly, being not very populated, which is of course part of their allure, there is not significant infrastructure than there is, for example, on the mainland. So many marinas, at best, have limited water, and at times may be marked as non-potable, not something you want to put into your tank. Pane Vino holds 100 gallons of water, which for the two of us can last us several days, and less if we have guests aboard. We did not want to have to modify our schedule due to water anxiety, so 2 years ago we added a Watermaker. So let's take a look at what we put in and why, what it ended up costing, and how it works. There are many different water makers on the market, and the selection process can be a challenge. Some things to keep in mind are available space, features, capacity, and ease of serviceability. We chose the 17 gallon per hour rated 12 volt DC model from Seawater Pro. Some important features to me were firstly that the Watermaker is modular, so separate components can be mounted in the space available. Secondly, it's completely manual, no electronics, no circuit boards, very simple. And finally, all the components, with the exception of the Seawater Pro's high pressure valve, are all off-the-shelf stuff items that can be found easily just about anywhere. Oh, and one final thing, the price is really good, but we'll get to that later. So let's take a look at the components and how it all works. We start out with the low pressure boost pump. This pump supplies the seawater at a relatively high volume, but a low pressure of 15 psi, which is completely adjustable, to the high pressure pump. For this, rather than make a new through hole to supply water to the pump, I teed into the existing washdown pump supply, and that's been working great. The boost water then goes up to two filters. First a 20 micron one that captures the larger material, and then a 5 micron for anything that passes through the 20. You can see that the 20 micron one has already captured quite a bit. I rarely see anything in the 5. Next, we have the high pressure pump. We turn this on once the boost pump is supplying water to it, and we turn the valve until we get about 800 psi going into the membrane. We should then see the flow of product water increase on the flow gauge. We are now making water. We have a valve that allows the water to flow out a length of hose for testing, and then we can turn that valve for the water to go into the tank. The Watermaker comes with a total dissolved solids meter for more accurate testing. The goal is to have it below 500 parts per million. Above is okay to drink, but it will have an off taste. However, we have never seen it above 65. It really makes some great tasting water. In fact, we prefer it over to the water that we get at most marinas. The salty brine water that gets rejected goes overboard. I was able to avoid making a through hole here also for that by tapping into one of the deck drain hoses. Finally, there is a freshwater flush system to periodically flush the system, and it has a timer. It's labeled as a Seawater Pro, but true to their claim that most parts are common off-the-shelf items, it really is just a rain drip sprinkler timer that you can buy at any hardware store. So let's talk about the electrical side. This is where Seawater Pro leaves it to you, and I'm fine with that as electrical is in my wheelhouse. I added a basic switch panel from West Marine. One switch goes right to the boost pump, as the amp draw is really small and well within the capacity of the switch. The second switch is interlocked with the first switch, so it will not come on unless the first one is on, which means the boost pump needs to be on to bring water to the high pressure pump. This switch goes up to a 12-volt universal solenoid that sends power to the high pressure pump through a high amperage Blue Seas breaker. All very simple and easily serviceable. So let's talk cost. Very simply, with our installation, the total was about $4,500, with $3,500 being the cost of the kit from Seawater Pro, and the rest being the electrical hardware and some contracted labor to make the exposed wood blocks and grind and epoxy them to the transom wall to mount the membrane. The exact final cost, I really don't know. And unlike some channels who have Excel spreadsheets and track all costs, we don't work that way. But this I do know, it was several times less than what we were quoted for other systems. And after 2 years, we've been very impressed. And I can drink to that, even if it is just water.